Recent observations of the interstellar object known as 3I/Atlas have sparked renewed excitement and curiosity within the astronomical community, as scientists have detected what appears to be a faint bluish hue emerging from the comet's coma. This subtle but intriguing color shift follows a dramatic and unexpected brightening event that occurred while the object was hidden behind the sun, out of direct view from Earth-based telescopes. Notably, this marks the third time since its discovery that experts have reported a possible change in the comet's coloration, although none of the previous shifts have proven to be permanent. Each apparent transformation has raised new questions about the comet's composition, behavior, and long journey through interstellar space, underscoring just how unusual and scientifically valuable this visitor truly is. 3I/Atlas holds a special place in modern astronomy as only the third confirmed interstellar object ever observed passing through our solar system. Discovered in early July, it was first seen racing toward the inner solar system at an extraordinary speed of more than 130,000 miles per hour, or roughly 210,000 kilometers per hour. Such velocity is a strong indicator of its interstellar origin, as objects bound to the sun typically move far more slowly. Based on current models and observations, scientists believe that 3I/Atlas may be the oldest interstellar comet ever detected, with an estimated age exceeding 7 billion years. This would mean it formed long before our own solar system, which is about 4.6 billion years old, making it a rare and ancient relic from another star system. Researchers suggest that 3I/Atlas was likely ejected from its home system somewhere on the outskirts of the Milky Way, possibly due to gravitational interactions with a large planet or a passing star. Once expelled, the comet would have spent billions of years drifting through the cold, dark expanse of interstellar space, largely unchanged and untouched, until chance alignment brought it into the sun's gravitational influence. Its current passage through our solar system is therefore a fleeting event on cosmic timescales, offering scientists a brief but invaluable opportunity to study material formed around another star. In early October, the comet made a relatively close approach to Mars, providing astronomers with a valuable chance to observe it from multiple vantage points. Shortly after this encounter, however, 3I/Atlas moved to the far side of the sun from Earth's perspective. During this period, the comet became extremely difficult to observe using ground-based telescopes, as the sun's glare overwhelmed any faint light reflected or emitted by the object. Only a small number of space-based observatories and solar monitoring spacecraft were able to continue tracking it indirectly, gathering limited but crucial data. The comet reached perihelion, its closest point to the sun, on October 29th. At that time, it passed within approximately 130 million miles, or 210 million kilometers, of the sun, about 1.4 times the Earth's average distance from our star. Although this is not an especially close solar approach by cometary standards, what happened around this time surprised researchers. Data analyzed by a pair of scientists studying spacecraft observations revealed that 3I/Atlas experienced an enormous increase in brightness shortly after it disappeared behind the sun. The brightening spanned several orders of magnitude and could not be fully explained by the modest decrease in its distance from the sun alone, suggesting that some additional physical process was at work. In the same preliminary study, which has not yet undergone peer review, the researchers reported that the comet appeared to be distinctly bluer than the sun. This observation was unexpected, as no such blue coloration had been detected during earlier phases of the comet's journey through the inner solar system. If confirmed, the blue hue could provide important clues about the comet's chemical makeup. Scientists speculate that the color change may be caused by the release of specific gases, such as carbon monoxide or ammonia, which can emit or scatter light in ways that give the coma a bluish appearance. These gases are particularly interesting because they are highly volatile and tend to sublimate or turn directly from solid to gas when exposed to increasing warmth. The idea that new gases are now venting from the comet's nucleus suggests that 3I/Atlas may be undergoing structural or compositional changes as it responds to solar heating. After billions of years in the deep freeze of interstellar space, The comet's surface and interior layers are being exposed to conditions they have likely never experienced before. As sunlight penetrates deeper into the nucleus, it may trigger the release of trapped ices that were previously sealed beneath layers of dust or more refractory material. This process could explain both the sudden brightening and the apparent shift toward a blue coloration. What makes this situation even more intriguing is that this is not the first time astronomers have reported changes in the comet's color. When 3I/Atlas was first observed in July, it exhibited a distinctly reddish hue. This coloration was widely interpreted as a sign that the comet was shedding large amounts of dust, which tends to reflect sunlight more efficiently at longer, redder wavelengths. Dust-rich comets often appear red or yellowish, especially when they are far from the sun and gas activity is relatively weak. Then, in September, some observations hinted that the comet was briefly turning green. Green comas are commonly associated with the presence of molecules such as dicarbon or cyanide, which glow green when excited by ultraviolet radiation from the sun. This green tint, however, was short-lived, and subsequent observations suggested that the color had faded or reverted to a more neutral tone. Now, with reports of a bluish hue emerging after perihelion, 3I/Atlas has demonstrated a remarkable variability in appearance over just a few months. The temporary nature of these color changes has left scientists puzzled. One possibility is that different regions of the comet's nucleus are becoming active at different times, releasing varying mixtures of dust and gas as they are exposed to sunlight. Another possibility is that the observed color shifts are influenced by viewing geometry, observational limitations, or changes in the density and structure of the coma rather than fundamental alterations in composition. Distinguishing between these explanations will require sustained monitoring and more detailed spectral measurements as the comet moves farther away from the sun and becomes easier to observe from Earth. As 3I/Atlas emerges from behind the sun and continues its journey, it is gradually becoming more accessible to Earth-based telescopes. Over the coming weeks, it will move northward across the night sky, making it particularly favorable for observers in the northern hemisphere. Although it will not be bright enough to see with the naked eye, amateur astronomers equipped with a decent telescope or high-quality binoculars may be able to spot it under dark skies. Professional observatories, meanwhile, will be watching closely, eager to confirm whether the reported blue coloration persists, and to gather more data on the comet's evolving behavior. Ultimately, only continued observations will determine whether this latest color change is a lasting transformation or just another fleeting phase in the comet's complex interaction with our solar environment. Regardless of the outcome, 3I/Atlas has already proven to be an extraordinary scientific treasure. As an ancient traveler from another star system, it offers a rare glimpse into the building blocks and chemical conditions that exist beyond our own cosmic neighborhood. Each new detail, from unexpected brightening to shifting hues of red, green, and blue, adds another piece to the puzzle, helping scientists refine their understanding of how planetary systems form, evolve, and occasionally send emissaries like 3I/Atlas drifting across the vast distances between the stars.